Now that we've learned the remarkable story of Mayer Amschel Rothschild, let's turn our attention to the principle that he believed was the secret to his extraordinary financial success. That principle is compound interest. In this chapter, we'll learn what compound interest is, how it works, and why it has such an extraordinary impact on building wealth over time. Just as importantly, we'll see that this same principle can either work for you or against you, depending on how you use it. Let's begin by defining compound interest. Now let's define compound interest. Compound interest is the interest earned on a principal sum that is calculated not only on the original amount invested, but also on the accumulated interest from prior periods. Simply put, it is interest earning interest. At the beginning of this program, we said that the only math we would use was addition, subtraction, multiplication, and division. Well, for this section, we're going to introduce something called an exponential function, so we're stretching our original bargain just a little. You'll see the mathematical formula for compound interest because it is the formal mathematical model. We'll identify its components, but we don't want you to spend any mental energy trying to understand the formula itself. Does that sound a little odd? Perhaps. The good news is that you don't have to become a mathematician to understand compound interest. The calculations can easily be done with a financial calculator or by using a simple shortcut we'll introduce shortly called the Rule of 72. Our goal isn't to teach advanced mathematics. Our goal is to help you understand one of the most powerful financial principles you'll ever learn. Here we have the mathematical formula for compound interest. We're going to briefly explain each element of the formula so you understand what the different variables represent. Now, let me reassure you, we don't expect you to memorize this formula or even fully understand it. In fact, if it still seems a little confusing after we explain it, don't be discouraged. Let's look at the formula. A represents the final amount. P is the initial principal, or the amount you start with. R is the annual interest rate. N is the number of times the interest is compounded each year. And 'tis the number of years the money remains invested. That's really all you need to know about the formula itself. In just a moment, we'll simplify everything by using an online compound interest calculator. Seeing the numbers in action will make the concept much easier to understand. And if you would like to study the mathematics in greater detail, we also have a supplemental study guide available. Now let's put compound interest into action. Rather than focusing on the formula, let's use an online compound interest calculator and see what happens over time. We'll begin with an initial investment of $5,000. Next, we'll contribute $500 each month. We'll invest that money for 40 years at an estimated annual interest rate of 8%, with interest compounded quarterly. Once we enter those values into the calculator and select Calculate, we'll see both the results and a graph showing how the investment grows over time. If you're in your 20s or even younger, time is your greatest advantage. Whatever you have to do, try to find a way to begin saving and investing something every month. Even if it's not $500, developing the habit of investing early can make an extraordinary difference over the course of your lifetime. Now, let's take a look at the results. Now let's look at the same example from a different perspective. This time, we'll use the same initial investment of $5,000 and continue contributing $500 each month. However, instead of investing for 40 years, we'll invest for only 20 years. We'll again assume an annual rate of return of 8% with interest compounded quarterly. Once we enter these values into the calculator and select Calculate, we'll see how much the investment has grown after 20 years. This example is intended for someone who may be in their 40s. Although you don't have as much time as someone in their 20s, compound interest can still produce impressive results. While time is certainly on the side of a younger investor, it's never too late to begin. Let's take a look at the results. Now I'd like to introduce one of the simplest yet most powerful financial tools you'll ever learn, the Rule of 72. The Rule of 72 tells us approximately how long it will take for money to double at a given rate of growth. Simply divide 72 by the annual rate of return and the answer is the approximate number of years it takes for your money to double. For example, suppose you earn 5% per year on an investment of $1,000. How long will it take for your money to grow to $2,000? 72 divided by 5 equals 14.4 years. Now let's look at the other side of the equation. Suppose your credit card charges 21% annual interest. 72 divided by 21 equals approximately 3.4 years. In just over 3 years, you will have paid the bank an amount in interest equal to your original credit card balance. That is staggering. Now let's look at another example. Suppose you invest $1 and earn 8% per year. Using a calculator, multiply $1 by 1.08 each year. After approximately 9 years, your $1 grows to about $2. The rule of 72 tells us exactly the same thing. 72 divided by 8 equals 9 years. Now consider Warren Buffett's remarkable investment record. Over approximately 40 years, Berkshire Hathaway averaged an annual return of about 18%. 72 divided by 18 equals 4. In other words, money doubled approximately every 4 years. We'll see just how extraordinary that is on the next slide. Can you believe it? The rule of 72 was developed by our double-entry bookkeeping friend Luca Pacioli more than 500 years ago. That is how long this incredibly simple yet remarkably powerful mathematical tool has been available to all of us. We are not pollsters, but in our informal assessment, 9 out of 10 people have never even heard of the rule of 72. And even among many who have heard of it, very few truly understand its implications. On the previous slide, we introduced the rule of 72 and mentioned Warren Buffett's remarkable investment record. Over approximately 40 years, Berkshire Hathaway averaged an annual return of about 18%. Using the rule of 72, we divide 72 by 18 and get 4. That means money doubled approximately every 4 years. Let's see what that looks like. Suppose you start with $1,000. 4 years later, it becomes $2,000. 4 years after that, $4,000. As you can see on the screen, the process continues, doubling approximately every 4 years. After 40 years, your original $1,000 has grown to more than $1 million. Buffett's 40-year average return of 18% is truly remarkable. It's no wonder that so many of his long-term investors became wealthy. To put that into perspective, about 40 years ago, I had approximately $200,000. Had I invested that money with Warren Buffett and achieved those same returns, it would have grown to roughly $200 million. I assure you, I have nothing like that. Even an investment of just $10,000 would have grown to approximately $10 million over the same period. Unfortunately, returns like that are extremely difficult to find today. Unless you're a credit card company or another lender charging very high interest rates, opportunities to consistently earn returns of that magnitude are rare. As we've already seen, credit card companies charging around 21% interest are doubling their money in approximately 3.4 years. So far, we've looked at compound growth in terms of investing and borrowing money. Now let's look at another example where the rule of 72 can help us understand growth over time, world population. For many years, the world's population grew at approximately 2% per year. Using the rule of 72, 72 divided by 2 equals 36. In other words, at a 2% growth rate, the world's population would double approximately every 36 years. More recently, the annual growth rate has slowed to about 1.5%. At that rate, the doubling time increases to approximately 48 years. Let's look at the numbers. In 1950, the world's population was approximately 2.5 billion people. By 2023, it had grown to about 8 billion people, an average increase of roughly 72 million people each year. To put that into perspective, the Second World War claimed approximately 75 million lives worldwide. That is less than 1 year's worth of average population growth. Today, the annual increase is estimated to be around 83 million people. The world's population grew from 7 billion to 8 billion people in just 12 years. Current projections estimate that by the year 2050, the world's population will reach approximately 9.8 billion people, an increase of another 1.8 billion people in about 25 years. Once again, we see the remarkable power of compound growth. Whether we're talking about money or population, the same mathematical principles apply. Now let's put everything we've learned into practice. If you'd like to see the power of compound interest for yourself, I encourage you to use the compound interest calculator available on investor.gov. Simply do a Google search for investor.gov. From there, select Financial Tools and Calculators. Next, choose the Compound Interest Calculator. In the following examples, we'll use that calculator to show how consistent investing over time can produce extraordinary results. Let's begin by looking at one possible path to becoming a millionaire. Now let's look at one possible path to becoming a millionaire. We'll begin with an initial investment of $350. From there, we'll contribute an additional $350 each month. We'll assume an average annual return of 8% and allow the investment to grow for 40 years. Now we'll enter those values into the compound interest calculator. Let's see what the results look like. Here are the results of our example. By investing $350 each month for 40 years at an average annual return of 8%, the investment grows to more than $1 million. Now 40 years is a long time, but let's assume you increase your monthly contribution by just 3% each year. According to the rule of 72, your monthly contribution would double in approximately 24 years, from $350 per month to about $700 per month. About 12 years after that, your monthly contribution would increase again to approximately $1,000 per month. The compound interest calculator doesn't perform that calculation for us, but it's clear that the final value would be substantially greater than $1 million. There are also many companies that pay dividends and increase those dividends by 3, 5, or even 10% each year. That creates another opportunity for your investment contributions to grow over time. The important lesson is this: start early, contribute consistently, and whenever possible, increase your contributions as your income grows. Now let's take a closer look at how that $1,156,000 was created. Over the 40-year period, the total amount you contributed was $168,350. The amount earned through compound interest was $987,650. Here is Rothschild's secret in full view. The interest earned is nearly 6 times the amount that was actually contributed. Think about that for a moment. You contributed $168,000, but compound interest earned nearly $1 million on your behalf. The final value of the investment is approximately $1,156,000. As we suggested on the previous slide, the final amount could be even greater if you gradually increased your monthly contributions over time. Still, this example makes an important point. Nearly $1 million was earned through compound interest, money you didn't have to work for directly. Your money was working for you. Now let's compare that example using a lower annual rate of return. Everything remains exactly the same. We begin with an initial investment of $350, contribute $350 each month, and invest for 40 years. The only difference is that we're now assuming an average annual return of 5% instead of 8%. Over the 40-year period, the total amount contributed is $168,350. The amount earned through compound interest is $368,332. This results in a final value of $536,682. Notice that the investment continues to grow because of compound interest. However, a relatively small change in the annual rate of return produces a significantly different result over a 40-year period. This example illustrates an important lesson. Over long periods of time, even a few percentage points of additional annual return can make an enormous difference in the final value of an investment. Now let's look at what happens when we reduce the investment period from 40 years to 20 years. We begin with an initial investment of $350 and contribute $350 each month. This time, we invest for 20 years at an average annual return of 8%. Over the 20-year period, the total amount contributed is $84,350. The amount earned through compound interest is $123,531. This results in a final value of $207,881. Once again, compound interest earns more than the amount actually contributed. However, as we have seen, time plays an enormously important role in the power of compound interest. 20 years can still produce impressive results, but the longer your money has to compound, the greater the potential impact. We want any person who is a teenager or older to review this program. If you are a teenager or someone in your early 20s, you have the magic of youth and correspondingly, time on your side. The power of compound interest is evidenced by our earlier example, where $168,350 was contributed and nearly $1 million was earned through compound interest. But what if you are not 15, 20, or 25? What if you're 45? Let's consider a married couple where each spouse contributes $350 per month. Together, they contribute $700 per month, starting with an initial investment of $1,000 and earning 8% for 20 years. Let's see what they can accomplish. Here are the results. Over the 20-year period, the total amount contributed is $169,000. The amount earned through compound interest is $249,241. This results in a final value of $417,241. Not quite the savings potential of a 20-year-old, but having more than $400,000 is certainly better than having nothing. We know, and you probably know, many people at age 65 who do not have $417,000 in savings. The future for people who have not managed to develop significant retirement savings is grim indeed. People who may have lived a middle-class lifestyle during their working years can find that they are unable to sustain that lifestyle in retirement.